So I would like to thank everyone for being here. And I would also like to thank the organizing committee of PyCon Thailand. They are really doing a fabulous job. And especially I would like to mention Frank Oz, who has been in constant touch with me since the first day of submission of my talk. So yeah, let me first introduce myself. My name is Tushar Bansal, and I am a pre-final year student at the LNM Institute in Jaipur, India. So recently I got certified as an open leader from Mozilla, and apart from this I am also a software developer, and I have a keen interest in web development, and I started working on NLP since last 3 months, and currently I am working on a project which is basically approved by Government of India, and the project name is Surveillance of Vehicle On-Road Activities. Yeah, so that was a bit about me. So yeah, now let's start with the topic. Basically, I will be discussing about developing natural languages application using Python. So anyone who has worked upon natural language processing or knows about natural language processing here? Okay, so let me tell. Basically, NLP is training computers to understand human languages like English, Hindi, or any French, Spanish, so that they can manipulate and they can understand it. So basically, NLP has gained a lot more popularity in last few years because of the vast amount of data available on the internet and social media. So it becomes very difficult for humans to analyze the data. Therefore, we need some tool to basically compute and find the analysis. So yeah, basically NLP is a branch of artificial intelligence, and it is important because there are a lot of implications of natural language processing in our day-to-day life. I will be discussing some applications. First one is information extraction. Let's suppose I have received an email from the PyCon organizers regarding the scheduling of meeting, PyCon conference at True Digital Park on 15th of June at 9 a.m. So I would like my application to automatically extract this information like True Digital Park and 9 a.m. 15 June and create a calendar entry for this. So a calendar entry will be created like the event is PyCon conference and date is 15 June and time will be 9 a.m. and venue will be True Digital Park. So basically modern email services have these kinds of application included in them. You might have booked a flight, right? So they are in your calendar, and when the flight just is about to be there, you get a notification. So yeah, it's being used in real world nowadays. And next is sentiment analysis. Like suppose someone is interested in mobile phones and he's scrolling internet to find out about which attributes user cares most while buying a mobile phone. For example, attributes like camera, microphone, battery, sound quality are some of the features about which users cares most while buying a mobile phone. So we want our application to automatically extract these features like camera, microphone, and find out how users feels about this. So a review like microphone worst quality is a negative sentiment regarding microphone. And similarly, a statement like camera takes good picture, it's a positive sentiment. Right, so these are the feelings according to the reviews, how users feels. So other applications include spam detectors. Basically 99% of the spam today are detected and are moved to spam folders. So problems like this are basically solved nowadays. However, problems like summarization in which the computer has to read newsletters like house prices increases or there is an increase in investment in factories, and it has to aggregate these statements and have to reach at a conclusion that there is a growth in economy. So problems like this are quite hard and are not solved yet. People are working on these kinds of problem. And another application include machines translation. Basically, if we want to have translation from one language to another. So this was much helpful to me in Bangkok because most of the people here don't understand English. So I use Google Translate to basically tell them what I am saying. So yeah, other applications include spelling checker. There are many applications. We will be discussing some of them in further slides. So yeah, now we will be discussing about some of the popular buzzwords in NLP. So basically tokenization. So anyone who has been working on machine learning here? So you might be knowing about tokenization. Yeah. So basically in tokenization, what we do is we break the large running text into small words. We call small, sorry. So basically we call these small words as tokens also. And the large running text may be broken into sentences, and the sentences can be further broken into words. Sorry. Yeah. So basically it is the, one of the basic step in natural language processing. So next is corpus. Basically it acts like a data set in natural language processing. It's a collection of large text. The text may be in one language or it may be in more than one languages. And next is stop words. Sorry. So yeah, basically stop words are something we don't want in our analysis. We remove this because they do not contribute much to the overall meaning of the text. So words like I, am, the, or any other word, we remove these kinds of words from. And next is regular expression. So you might have used regular expression in web development also. Yeah. So basically regular expression are streams of characters, and these streams of characters are used to match patterns in a string. So a regular expression like /d is used to match any digit in text, in the text. Yeah. So next one is information retrieval. Basically information retrieval is the process in which we extract the most relevant information that is used in our task. So the best example which I can quote here is Google search. Google, when we type something on Google, it extracts the most relevant information. It extracts the most relevant information according to a query. So there are many keywords. Next is basically text pre-processing. In text pre-processing, it is one of the basic steps in NLP, and every task needs the text to be pre-processed, and it includes many steps. The first one is to convert the uppercase letters in the text to the lowercase letters. We will be discussing an example of this. I have made a project on this, so we will be discussing a project at the last, and we will be using all this in the project. So we convert all the uppercase letters to lowercase letters, and we can do this using toLower function in Python. And next we either we remove all the numbers, or we convert the numbers to words. So we can remove numbers using regular expression, as I told you that we can use /d to find all the all the numbers in this string. And next we remove all the punctuation and white spaces. Basically we do not remove white spaces between the words. We remove white spaces at the end and at the start of the word. And we can do this using split function in Python, and we remove punctuations using translate function in Python. And next, removing stop words, tokenization, stemming, and lemmatization. We will be discussing about these four in detail in further slides. Yeah. So as I told you that basically tokenization is breaking the large text into small words. So like phrase like friends, Romans, and countrymen. We apply tokenization, and it will be broken into words like friends, Romans, and countrymen, and we represent this set as capital N in sets, right? And V is the size of the vocabulary, and vocabulary is basically all the unique words. In tokens you might have duplicate words. So yeah, there are many issues in tokenization. At the first we need to decide what will be the standards of tokenization for each word. For example, in this word Finland '(S) with capital F, we need to decide how we need to tokenize this. Either we can tokenize it by removing the apostrophe and S, or we can tokenize this just by removing the apostrophe, or we can keep it like that only. Similarly, in this Havlet packet, we can either tokenize this into one token or two token, like Havlet packet in one word or in different words. And even more complicated is the task of tokenization in other languages like German or Chinese or Japanese. In German, basically, we do not have spaces between large nouns. For example, like this, in this statement like life insurance company employee, this statement is written like this in German. So we need to apply word tokenization in this. And in Chinese, we do not have basically we do not have spaces between the words. So what we need to do is we need to segment the words, we need to find all the different words, and the algorithm which is mostly used here is maximum match algorithm for segmentation. We will be discussing about this algorithm sometime later. Yeah, so next is basically lemmatization. Lemmatization, basically in this, every word needs to be lemmatized first before further processing in an NLP. So first, basically, we reduce each word to their inflection of from their inflection of variant form to their base form. It's not like stemming, in which we basically chop off the last few characters from the word. So basically, it uses morphological analysis to convert the word. For example, words like M, R is converted to their base form, that's B. Similarly, cars apostrophe S, cars apostrophe are all converted to their base form car. And in the face, the boy, car are different colors. Boys is converted to boy, different remains different, and R is converted to B. Colors goes to color. So next is stemming. So before moving to stemming, let me tell you what are stems and what are affixes. So basically, stems are the core meaning bearing unit in a word, and affixes are the bits or characters that are appended at the end of the word, so that like in affixes, the word affix is a stem and es is a affix itself, and in the word meaning, mean is a stem and ing is a affix here. So we will be reading in this in further slides. So basically what we do is we chop off the last affixes from this word, and we reduce the word to their stem. And yeah, of course it's language dependent. So example, words like automate, automates, automatic, automation, these all words are reduced to automat. And in this phase, compressed, compression are both reduced to compressed, because it's the stem of these words is compressed. And we can either convert this R to AR using stemming, or we can use lemmatization to get R. We convert R to B. We can either convert it to AR, or we can either convert it to B. Right, so an equivalent gets converted to equal. Next, the base, the most common and the most simple algorithm which is used for stemming is the Potter's algorithm, and we basically use this for English. And basically, it contains a set of rules in which the first step is what we do is the words ending with SSES, we chop off ES from these words and it gets converted to SS. For example, in the word like keresis, ES gets removed and it converts to keres. Similarly, the words ending with IES, we remove ES and it gets converted to I. Like in ponies, it gets converted to pony. So we exploit these rules in a fashion, in a particular order. So even after applying these two rules, if 2S remains, we don't change it, we keep it as it is. Like in keres, it remains keres. And however, after these three steps, if a single S remains, what we do is we remove this S. And like cats is converted to cat. And next is step 1B. In this, basically, we chop off the words ending with ing or ed. Like in playing, we convert it to play, and the word plastered is converted to plaster. So proper care is taken while applying the Potter's algorithm, that only the words which have a vowel at the beginning of ing or ed, only those words get converted, right? So for example, in this word sing, there is no vowel before ing, there is only a word character s, so it remains same. And similarly, the further steps include the words ending with ashner, iser, ater, these gets converted to ate, iser, ate, so on, right? And we will be using this algorithm in our project. We will be discussing in further slides. So yeah, next is language modeling. Basically, most of the tasks requires language modeling in NLP, and basically it is one of the most important topic in NLP. So basically, the goal of language modeling is to calculate the probability of a sentence or a sequence of word. So basically, it is very important, as like in machine translation, we need to distinguish between good translation and bad translation. For example, in this word, high winds in India is a better translation rather than large winds in India. So we need to distinguish between good translations and bad translations using probability. And similarly, we need this in spell correction also. There is much likely that someone may mistype minutes as minutes. So we need to assign high probability to the word, to the phrase with correct spellings. So we do this using probabilistic language models, and we have used this in Word file or creating any presentation. So many Google also uses, and every text editor also uses this. And even Twitter is using this to formulate its own sentences. They are formulating these sentences, they are formulating tweets by themselves using robots. So they use language modeling to basically create new sentences by robots. So yeah, as I told, the main goal of language modeling is to calculate the probability of a sentence or a sequence of words, and we represent a sequence of words as a capital W from W1 to Wn, and we can also use this probability to calculate the conditional probability of the next word. So for example, we want to calculate the conditional probability of word 5 given all the previous words. So any model which can compute either of these probabilities, that is the joint probability of the sequence of word or the conditional probability of the next word, we call this model as language language model. So yeah, how can we compute this probability of this statement, like its water is so transparent? So you might have studied the chain rule in your higher schools. So according to chain rule, we will be using chain rule for this. According to chain rule, the probability of a sequence of word can be calculated by just multiplying probability of the first word times the probability of second word given the first word times probability of third word given first and second word, so on. So similarly, like in this statement, a probability of its water is so transparent, we multiply it by first taking its and then water with its previous words, and then is taking its all the previous words, and so on. So how can we calculate these individual probabilities? We can't count the number of statements which have its, water, is, and we can't count the statement which is having its, water, is divided by the count of the statement in which its, water occurs, because there are a lot of many statements available on the internet, and we do not have that much large data set to basically find out these counts. So we take an assumption here. We use Markov's assumption for this. Basically, according to Markov's assumption, what we'll be doing is, for calculating the conditional probability of a word given all its previous words, we can use just few previous words. Like we can either use the last previous word, like in so, or we can use two previous words like is so. So more formally, we can say that the probability of a sequence of a word gets converted to probability of conditional probability of each word. So we multiply the conditional probability of each word. Yeah. So yeah. So basically, using the Markov's model, we can formulate an n-gram model in which we take this k as n minus 1. Yeah. Sorry. We take value of k as n minus 1, and the formula goes like this. And the most simple and the most basic n-gram model, which is used in almost 90% of the NLP task, is unigram model and a bigram model, in which we have value of k as 1 and value of k as 2 in bigram model. So in unigram model, we calculate the probability of a sequence by just multiplying the probability of individual words. However, in bigram model, we calculate the conditional probability of each word given all its previous words using just the last word, just the previous word. But it has been found that this model don't work well where the sentences have longer dependencies. For example, in the statement like the computer which I had just put into the lab on the 4th floor crashed. So if I haven't seen this word crashed and I want to guess this word, so I want to guess this word, I am using this to formulate the statements automatically, and I want to find this last word using just the previous word. It's less likely we will be guessing it right. And instead of that, if we know that the computer is the main subject here and crash is the main verb here, so it is much more likely that we will be guessing this correctly. So we can extend this n-gram model to trigram model, 4-gram model, and further. Sorry, let me have water. Yeah. So we will be discussing about popular Python library which is used for NLP tasks. The first one is NLTK, Natural Language Toolkit. So basically, it is one of the most powerful library available on the internet for doing NLP, and it has all the functions. However, there are some basically cons for this. We will be discussing about them in further slides. So, for example, we want to tokenize the statement into sentence, like the text "good is great, God is great, I want a lottery." So we want to tokenize this statement into sentence. So we can use this send underscore tokenize, and we can pass this string to this. So it will automatically tokenize this into statements. So a list will be created with a string "good, God is great, and I won a lottery." And for tokenizing it into words, we can use word underscore tokenize and pass this string to this, and it will tokenize this into all the words. However, you can see that it is not tokenizing it in correct way. Like in the word with apostrophe, WO gets separate and N apostrophe T gets separated. So what we can do is we can use other function for this. There are many functions for tokenization available on the NLTK, available in NLTK. So like regular expressions, regular tokenizations, we can use this so that we can get won't as a one word. Yeah. So can anyone tell me why we need a sentence tokenizer even though we have word tokenizer? Basically, at the last we want every sentence to be tokenized into words. So yeah, basically suppose we want to calculate the average number of words in a statement. For that task we will be needing statement tokenizer, and also statement tokenizers are used to basically find how the user or the reviewer feel for that particular thing about which he is writing a review. So this is used in that. Yeah. So we need to remove the stop words from the our text. So first we can get all the stop words using the words function in stop words module, and we pass the language for which we want to get the stop words, and we store it in a list. The name is ENG, and we get the words like I, me, my, myself, we, our, us. These are all stop words. And if we want to remove these kinds of words from our text, what we do is we first tokenize this text. Text into words, and then what we do is we iterate through all the words, and we find out the words which are in the words tokens and which are not in the stop words list. So we iterate a loop, and we append all the words which are in word tokens, which are in this which are in the tokens of this statement, and which are not in stop words list, and we print this. So in this is removed, as you can see, of the is removed, and further. Yeah. So yeah, as I told you, we will be discussing stemming using Potter's algorithm. Basically, we create an object for this. We create the variable name is PS, and we create an object for this, and we tokenize this text into words, and we call ps.stem function for each of the words. So as you can see that programmers gets converted to program gets converted to program only, with remains same, and programming we stem this ing, we chop off this ing, and it goes to program, and languages es gets eliminated. Yeah. So to do lemmatization, we create an object for this module. We create an object for this module, and we call a function lemmatize for this, and pass the word for which we need to find the lemmatized version. So rocks becomes rocks, and corpora goes to corpus, and better goes to good. So lemmatization, as I told you, that it uses morphological analysis for it. So we need to pass the part of speech for this. So in this we are passing a speech as adjective, right? So even if we do not pass this, it assumes that it is a noun. So it assumes that rocks is a noun or corpora is a noun. And in this we have explicitly mentioned that better is adjective in this case. So the pro and cons of NLTK, basically the pros are, it is a full NLP library. We can build a project on NLP using only this library, and basically it has plenty of approaches for each of the tasks, and it supports many languages. You have Spanish, French, Hindi, English, or basically we have Tamil also. Tamil is used in India, southern India, and the cons are basically it's very complicated. The task in this, the implementation is very complicated, and it's a bit slow. Next we will be discussing a library which is TextBlob. It's much more faster than this, and it has all the functions as an NLTK. and it doesn't use neural network for training, like deep neural network for training. So yeah, next we will be discussing about text blob. Basically, text blob is much more simpler than NLTK, and it has all the functions. And yeah, so basically to find all the noun phases in a text, we need to find all the noun phase in a text. So we can use a function. We first pass the file in which we have the text stored, and we read it, and then we create a blob. Basically, this it is a object for this, and it returns an object. And we call the function noun underscore phases for this, and it finds all the basically all the noun phrases. However, sometimes it gives a problem because it finds nouns, it finds proper nouns. So as you know that proper nouns have first characters as capital, and the statement starts with a capital letter. So all the first word in a statement gets also converted as noun phrases. Yeah. So basically polarity is basically used in sentimental analysis, and basically it is what is the sentimental orientation of a statement. So it returns a score between -1 to 1. -1 tells that the user is feeling 1 tells that this user is happy, and -1 tells that the user is feeling horrifying. So what we do is we first tokenize this statement using sentences. As I told, sentences are used for finding the polarity. So we first tokenize it into sentence, and we find the polarity of each of the sentences. So as you can see that in this statement, text blob is an amazing simply to use. What grades fun? So basically, as you can see that there is a probability greater than 0. That means the user is happy about that. This statement, the user is happy about this. So yeah, next is sentiment analysis using text blob. Basically, it returns two properties. First one is polarity, as I told you in previous slides, and other one is subjectivity. Basically, subjectivity tells how much the statement is a fact, or either it's an opinion or a judgment of the person itself. So it has a value from 0 to 1. 0 tells that it is a fact, and 1 tells that it is a personal opinion of the person. So for example, in this analytics Vidya is a great platform to learn data science. So if we want to find the polarity of sentiment of this sentence, we use the function sentiment, and as you can see that the polarity is 0.8. It means that the user is happy about this. The user is happy with Analytical Vidya website, and the subjectivity is 0.75. It tells that it is a particular feeling of that person. It's not a fact. If this value is to 0, then it's a fact. Yeah. And you can find the n-grams. Basically, we will be finding bigrams in this, and we can use the function n-gram and passing the variable 2 for bigram model. And if we pass 1, it will find a unigram model. And we print all the n-grams. So you can see that it basically combines every 2 words in continuous fashion. So analytics Vidya is an great, and so on. Yeah. So next I will be discussing about my project which I built. Basically, I built with my friend, my college mate, and the project name is Word Cloud Generator, and it's a sentimental based project. Yeah. So the goal of this project was to to analyze the sentiments of the person who are visiting India, basically Rajasthan. Rajasthan is a state in India. It's too hot nowadays. They are around 50 degrees Celsius. So yeah, we want to find the sentiments of the person who are visiting India, and we want to find how they feel and what was their travel experience. So what I did was I collected the database, the tweets from Twitter, which had hashtag Rajasthan travels in it. So I collected this using the Twitter API, and in this I plotted a word cloud for this. So the words which are in green represent that there was a sentiment, positive sentiment about these words from the users, and the words with red means that there was a negative sentiments about these words, and the words with white represent that there was a neutral sentiment, and the size of the words represent that what was the frequency of these words in the text, right? And the intensity represents how much happy or how much sad. The intensity of the color represents how much sad or how much happy he was with the basically the experience. So we basically divide this into green words which represent positive sentiments, white words which represents neutral sentiments, and red words which represent negative sentiment. see that most of the words are green here. So the overall sentiments of the tourists were positive. That means they enjoyed the tour to Rajasthan. So yeah, another thing which I did was I basically plotted the number of tweets for 3 consecutive days. And as you can see that there was a high increase in number of tweets on the second day. So it means that there was a public holiday, or there was an event on that particular day. So people were traveling here and there, and they were basically tweeting about that. So basically government can use this to basically prepare in advance for managing the resources and all. Yeah. So I will be telling about the procedure how I did this. First I collected the data set, and the data set the data set looks like this. It has ID. Basically every tweet on Twitter has a unique ID, and the date and the text. This is the tweet which the people made, and since this column was of no use to me, I just dropped this column, and after dropping it looked like this. Yeah. Next I converted all the uppercase letters. As you can see that all the uppercase words are converted to lowercase words, and I also removed the punctuation from this. The lowercase I converted using toLower function, and for the punctuation I found all the words which are all the characters which are not words from this using regular expression, and the regular expression is /w. You can find all the characters which are not words using /w, right? And then we removed all the emojis and special characters and white spaces from it. The white spaces are removed using regular expression, that is /s. /s basically removes all the white spaces and tabs. So the text looks like this. Next, we dropped all the rows which had no entry in that. So it was of no use, because the entry which have no value in this, they were of no use. So I dropped all these. And then I basically I removed the duplicate entries in this. Like here we have a duplicate tweet, so I removed that. And then I also resetted the index for this. I reset the index for this all. Yeah. And the next part I did was I tokenized these text. I tokenized this text into words. I find all the words, and then I found the polarity of each word. How was what that word tells about the sentence. The positive word is having a polarity greater than 0.1 or equals to 0.1, and a negative word has a polarity less than or equals to 0.1, and for a neutral word we have a polarity 0. For example, the positive words goes like this: India, Pushkar, Udaipur, Ashok Gehlot, village. The people were having positive sentiments regarding these words, and they were having negative sentiments regarding these words, and neutral sentiments regarding these words. And by the way, Pushkar Udaipur, and he is the CM of Rajasthan. He was the CM, currently he is not the CM, and these are the cities in India. So yeah, next what we did was I plotted this on word cloud. You can use the word cloud module for this, and I colored all these positive. I colored these all positive words as green. I colored these as red, and this is white, and I used the word cloud library for plotting this on this, right? So yeah, that's all from my side. Any questions?
Thank you very much for this beautiful talk. The floor's open for discussion.
Would you, the duplicate tweets, were those like retweets?
Hmm.
So would you consider adding that as a signal in your model? Because it's like another person saying that they agree with that statement.
Yeah, but having a duplicate entry will just increase the frequency of that word, and it will just increase the positivity of that word. If that word if you have tweeted the same tweet 10 times, it will just increase the frequency of each word, and that would not be fine, right? So that's why I removed the duplicates from that. Yeah. Any other questions? Okay. Thank you.
No, wait. I think there's
Okay. Sorry.
Yes, sure, please.
So in your word cloud
Yeah.
project, so the size of the word correspond to what? To frequency?
Yeah, it corresponds to frequency. I counted all the words, I created a map, and for each word, I counted the frequency, and according to that, I plotted on that word cloud. You can find the code on my GitHub repository. The links are below.
Thank you. Another question?
Okay, thank you for speaking. I'm thinking about a retweet.
Okay.
There's another kind of retweeting. For example, somebody retweet and add some comment on top of the tweet.
Yeah.
Did you remove that?
No, I didn't remove that because they are having some of the words new. Some of the words are new in that case.
I don't know about the API, but it's going to return the original tweet and say that it's also the content of that tweet or it's another tweet.
Basically, what Twitter API does is, if someone has retweeted that, it finds all the words the other person has added also. So that will. So if someone has added few more words, that will be in that text column. So if we match both strings, they will not be same. So they will not get eliminated in that case. Yeah.
Thank you.
No, thank you very much.
Thank you. If you have any other queries, you can contact me at any of the below handles. Yeah. Or you can meet me outside.
Okay, thank you very much. So we have a 10 minutes break and then